I don't need no audio. Hey, it's a screen. Like, I think because I work with technology, anytime it actually works the first time, I'm like shocked. Right? I'm just used to software just never working. Keeps us all employed though, so it's cool. One day we'll just finish software and it'll be done, and we can all open vegan food trucks and it'll be great. One of the things I've realized is that like the longer someone's in tech, the more they have their immediate exit plan. Like when this all falls apart, I'm going to do X, vegan food truck. I'm not a vegan. All right, let's get into it. So we're going to talk a little bit about resolvers, right? I have a hypothesis that I am not going to validate because if I'm wrong at the beginning of the talk, it's going to take away all my mojo. So I'm just going to say things and not actually like poll the audience, because if you're like, yeah, well, we've all written resolvers, like it's going to be a rough 20 minutes together. So my hypothesis is that GraphQL is not unlike promises, which is we all end up consuming a lot of promises. Yeah, just put .then, it's cool. Right, and then the moment you have to like create your own promise, like one time a year that happens, you're like, what is this black magic? It has like a new constructor and I got to pass in a resolve and reject. I don't know what's going on. And so there's a lot of cases, like if you use Gatsby, for instance, or AWS AppSync, or what have you, you're like, I got a GraphQL endpoint. I'm going to GraphQL there's a child here, the stuff out of this. He's mine. I can curse in front of him. But like, what happens when you want to sit down and like write your own GraphQL backend, right? Then you're like, oh, okay, this is different. Well, my job today is to try to convince you it's not that bad. And so we'll kind of go through it, and then you can do all sorts of crazy stuff. So as mentioned, my name is Steve. And I also work at Twilio. We did not plan this, despite the fact that we sit 12 feet from each other. And these talks also kind of like play off of each other. Again, not planned. I looked at the agenda. Oh, yeah, Craig's speaking. Right on. And a lot of interesting things you can do. Like, let's say hypothetically, this is a total hypothetical situation. You work at a company that's predominantly focused on developer APIs. Hypothetically. Not that happens where we work. And they can be a little tricky necessarily, like, all right, now you're going to build these like robust client-side apps on top of them, and you don't necessarily always have the API that works well for like building integration that sends text messages or emails is not always necessarily the best API for building a front end. Happens. Right? Like, as a shareholder in Twilio, I'm cool with the choices that we made. As an engineer that occasionally gets to write code these days, like, I would like sometimes the APIs to be a little bit different. So, yeah, Craig mentioned a little bit like backends or front ends. This idea that like you put a middle layer in there, you have a little bit more control, so you're not just doing it all client side or doing like, all right, here we'll do a poll of the audience. Raise your hand if you've ever had to do like an embarrassing set of AJAX requests to get the data that you need. Yeah, that one's easy. And so that you can begin to figure out ways around that. And we're going to be working with just like regular old JavaScript today. And so yes, could you abstract one API and make it a GraphQL service? Yeah. Could you like put together multiple APIs from disparate places and create one GraphQL endpoint that works? Totally. Could you write a GraphQL endpoint that like reads and writes in the file system? You shouldn't, but you could. Like, what you choose to do with this knowledge is not, I'm not responsible. Like, assume that there's like an MIT license here, right? Do whatever you want. I'm not accountable for your actions after this. So yeah, we're going to talk a little bit about how you go about doing that. We'll start out with like an in-memory data structure. We'll look at something that makes like API requests and begins to abstract it, and it'll all be a lot of fun. All right, so what is a resolver? The short answer is that it is a function or method that resolves a value for a type or field in your schema, because who does not like definitions that use the word that you're trying to define in the definition? Basically, you start going through that GraphQL tree and you try to figure out what the person asked for, right? All right. So, we asked for, the ID and the name of an artist. Okay, like, how do we actually get that? And so what happens is, as Craig mentioned, we break it into an AST, which is just a fancy term to take that wall of text and turn it into a tree that you can traverse. Like, Most of us who have been in front engineering are familiar with traversing trees. It happens. And so you go through and until basically you jQuery the thing until you find exactly what you're looking for. Except it's not jQuery. It's, you use a computer science term so everyone takes it seriously. And so we go through the tree, and if we get to a field or a type that is a string or a number or a Boolean or something along those lines, like, cool, you're done. Like, get the string. You've reached you've reached the leaf of the tree. If it's another object, we got to keep resolving, right? So, I'll show you, we'll get into this in a little bit, but the example we're going to do is kind of like an iTunes or Spotify app, right? So you've got songs, you've got albums, you've got artists, right? An artist has albums, an album has songs, but you might want to be able to start with the album, so on and so forth. So if you get to, the name of a song, well, that's a string. Done. Right? But if you get to an artist, you want to get to the albums, well, now you got to figure out how to actually make sense of each album. So you work that tree until you figure out, all right, we've got primitives the whole way down. We can actually just return a JSON object and we're good to go. So yeah, we keep going until we get to the bottom of things. So here's like a very simple schema that we have. We'll just start out with just an artist. And the artist will have an ID and a name, right? And we'll go and get all of them. Right, and here's what we're going to query for. Like, go get me all of the artists. Now, how would we actually write a very simple resolver that'll actually fit on a slide? So, all right, first thing to notice, the resolvers is just a JavaScript object. Now, yes, you can do this in whatever programming language you want. I use the one true programming language. And it's an object called query, and that's got a method called artists, at which point now I've just hard-coded in just some results, right? But you can see that at that point, we're just down to primitives the whole way, and we'll go back and we'll actually get what we're looking for. Now, that was just, hard-coded in. Like, that's probably not worth doing, except it makes you feel good because you get something on the screen, and sometimes it's about just keeping your, just staying happy, That way you don't run off and quit and start a vegan food truck. Resolvers can also be asynchronous. So we returned just a value there, like in that first one with artists, right? Cool, it was just an array. Obviously, like, you probably have to figure out what an artist is, and we'll get to that. If you look at the very bottom, you can also return a promise. And if you return a promise in the resolver, like most of the libraries, Apollo, what have you, are smart enough to wait till that promise resolves to hopefully either an object or a primitive, at which point we can keep going, right? You don't necessarily have to worry about that. If you return a regular old data structure, cool. If you return a promise, we'll resolve that promise and we'll keep going. So it can be synchronous, it can be asynchronous, and the albums is just, if you just want to prove a point to yourself that this works, you can make an immediately resolving promise. That's also how you make a promise. We learned two things tonight. It's going to be great. As you work down the tree, the siblings are executed in parallel, right? So in this query, we're going to try to get all the artists and all of the albums at the same time. Those will both be executed simultaneously, right? And so if you wanted to necessarily like have just the albums for a given artist, this is not going to work for you to ask for both at the same time. Now, you're not guaranteed the order in the same way that even JavaScript objects, you're not guaranteed the order of the keys ever. But like most of the time, it just works the way you want it to. But you can't actually like rely on that. So yeah, if you have two like kind of sibling nodes in your query, like both of those are going to be executed at the same time. And then, but if you go down the tree, you've got to wait, especially for the asynchronous stuff. You got to let the promise resolve before you can keep going, get some of that data. Cool. Yeah. So like I said, if we resolve a promise, we need to like, wait, chill. You made an AJAX request. It's going to be okay. Like, just relax. And when we get that data, then we will go ahead and we'll start working down that tree. So in this case, before we're getting artists and albums at the same time, this time we're going to go ahead and get the artists, and then we'll get the albums for that one. So that'll actually happen more in serial, right? So it all depends on how you structure the query, but the resolver doesn't change. It's how the person asking for the data is actually going to go ahead and get the stuff differently. All right, so again, just to kind of set the example, just like the iTunes app where you can start in any of like really 5. Let's focus on those middle 3. You can get all the artists, and once you click on an artist, you can then see their albums. When you click on an album, you can see a song. Or you can just say like, no, give me all the albums and I will go and figure this out. Or the third one, which nobody has ever used, which is just show me all of the songs in my iTunes library. and I'll figure it out from there. Also, let's be really honest. Our hearts fill with dread every time we see the iTunes thing on a Mac open. You're like, can I just get this off of my computer? Nobody is actually on a Mac ever asked iTunes to open. They went to charge their phone on their computer, and now the little thing's bouncing, and it's got a lot of notifications for you, and it's bad. So this is a hypothetical one, but the Spotify screenshot didn't make my point. So here we are. All right. So I don't think that I have to sell you on using GraphQL. Maybe I do. Maybe you're like, I'm skeptical. I came to this thing to, heckle. If you have tomatoes, that's fine. You can throw carrots or whatever. It's cool. So yeah, like they might want to do all these different things, and GraphQL is really good for. That's a lot of endpoints. All right, let's just do the albums. Then we'll do albums by artist. Then we'll do songs by album. The amount of endpoints you're going to need is tedious and boring, and at no point am I ever going to enjoy doing it, and I don't want to. I think the famous Larry Wall quote, he's the guy who made Perl. I think that's good context, is the 3 most important characteristics of a programmer are laziness, impatience, and hubris. Right, and so creating one GraphQL service where they can just go get whatever they need for whatever view they need is going to be a lot easier than making 1 billion endpoints. It's a technical term. All right, so what could the schema look like for this? All right, for an artist, we'll have names. That artist will have a number of albums. But we could also get, let's say, hypothetically, all of the songs for an artist, too. So, forget the albums. We only know there's only one good song on that album. I don't want to listen to the rest of that trash. We can view it, so we can go for songs for a given artist or albums for an artist. For an album, same idea. We might want to reference back up to the artist. And we also want to get all the songs on that album, as long as what year it was, too. I don't want to talk about how much time I spent on the dummy data for this application. It's not important. I didn't do it at work. It's fine. A little bit. So, and then for a song, we will get the title, the time, the artist, and the album that it's on, right? And so in this case, title's a string, time is an integer. That's not true. It's really a string. And artist is now, we'd have to go figure out the other data. So there's some circular things going on here that our resolver is just going to basically take care of for us, and we'll seem very smart. And they'll be able to do the following queries on it. Get me all the artists, get me all the albums, get me all the songs. Pagination is not a thing because there's only 3 artists in here. And we'll have the ability to add songs, or get me a particular one as well. All right, just to kind of, I was going to say greatest hits, but that would have been an accidental pun, so I won't say it. Let's just talk about what the data looks like that we want to be able to use as well. I'm sorry, I was a sociology major. What the data look like. Data is plural for datum. So, we might want to get, in this case, the artists. If we go ahead and we get the albums, there's obviously more in the data set, but this is kind of what it looks like. Right now it's just 3 JSON files. And we only have the IDs in there. We don't have a bunch of circular references, but our resolvers will figure all of that out for us. We are not going to have to worry about that as long as we know the ID of the artist, the ID of the album, so on and so forth. Our resolvers will figure all of that logic from a series of arrays, and it'll be good. And then we'll do it with some AJAX requests from Discogs as well. And here are the songs. As you can see, they reference the artist ID and the album ID, so on and so forth. Cool. All right, let's get into it. So a resolver, the one I showed you on the screen before, we just hard-coded in a data structure, and we didn't deal with it. Turns out that each one of those methods on that object takes 4 arguments. You can use none of them. You can use all 4. I've never actually seen info used, so we're just going to ignore that one. Root or parent is, as you're working down that tree, the parent is going to be the last one you just resolved previously up the tree from where you are now. Right? This is useful for, all right, we figured out what artist it was. We're getting the albums. Right? But if you're going to make an AJAX request, you need that artist ID. Cool, just look up the tree. You just got the artist. You can get that artist ID. Args are any of the arguments that you gave to the GraphQL query, right? So the ID of the one you're looking for, if it's a mutation, the data that you're putting in there, so on and so forth. Context, which we'll talk about a little bit more later, is a shared object that can be passed all the way down through the resolver. It could be, for instance, the database connection, or if you're hooking up to like a Express or a HTTP service, it might be the actual HTTP request, so you can get more information, right? You might put the like authorization header in there, stuff that you're going to need to do your job that all the resolver is going to need. So you can actually just pass that in, especially, most of our examples, one file, but especially as you start to break stuff up, you pass in the context object in the very top, it gets passed through to every single method so everyone has access to it. You can mutate it too if you want. It gets destroyed in between every request. All right. So that was our super simple one that didn't use any of those, but really these 4 things are always getting passed in one way or the other. All right, so args we talked about a little bit. It's going to be whatever we pass in there. In this case, the ID, if we're looking for a particular artist, is going to be, all right, whichever integer they passed in there. That way we can find what artist we're looking for. Again, like other stuff if you need it as well, but this is, I got to fit it on a slide, so we're keeping it simple. So in this case, args.id would be 1, because that is what we're passing into this query. It's going to get us the national. All right, so then we can use that to go ahead, like go through the array of all the artists and find me the artists whose ID matches the argument that was passed in. Again, and I happen to know this data set, so it will be the national, and it'll come right out like that. If you put in 2, it would be Camp Cope. And descending down the tree, that's where some of that parent works out really well. So an artist, we want to go ahead and get the albums or the songs. So once we get to the very first node on the tree, we're like, oh, that was an artist. All right, cool. So by default, and there'll be another slide for this, but I'll say it twice because it doesn't hurt. What happens is if you do not write, like, so we knew that artists had names, right? So when you say like, hey, I need the name of that artist or the ID of that artist, it checks that object, right? Like, cool, just get me the name. Like, you get it for free because you don't need to go like, name, cool, artist.name. Fine. But stuff like albums or songs or really anything that you want to do custom, because you can put whatever you want in here, right? It's just JavaScript. Famous last words. You can go ahead and figure out what is it when we say all the albums, what does that mean? So the artist, before you had query, now we have artist, which is now we're defining additional properties on that aren't on the actual artist object itself that had memory. We'll go ahead and figure out how to go about doing that. So the artist is that root or parent argument. I'm calling it artist, but you could have called it root. You can call it parent, you can call it whatever you want, which is go through my array of albums and look for the album's artist ID that matches that artist that we just evaluated. Right, same thing for songs. And like, again, I'm just using in-memory data structures, so I'm just using all array methods. It's fine. Like I said before, like for name and ID, this is what's happening under the hood. You could write that yourself. If you need to override it and put custom logic, you can do that as well. I'll show you some sample code where, let's say for a given song, we want the artist name and the album name, right? Now, could we, all right, for a song, then I want to get the artist, and then I want to get the name property. Or you can be like, I just want to make an artist name property that's not on the actual data, right? But I want to add that as a thing that they can actually add in their GraphQL query. You can add additional ones on top of just the relations. But like, we get all the basic properties on that object for free. This is like, that name one is what's going to happen if you don't define something. It's going to look on that object. So we don't have to do that. All right. Let's talk a little bit about mutations. Mutations, again, that first one is the root. You can use an underscore. You can put root or parent, whatever you want. Depends on like how obnoxious your ESLint rules are, where it's like, I'm sorry, you said parent, but you didn't use parent in this method. I don't know why we do this for a living. At which point we'll take those arguments, I'll make a new object, I'll generate an ID, I'll push it onto the array. In this case, you might make a post request with the API. If you have the database object, you might just actually insert it into the database. You can use Mongoose. Whatever you want to do in here, it's just JavaScript. You get to decide when the person using your GraphQL service makes one of these either mutations or queries. You can decide how exactly that's implemented. You can do whatever you want here. I just push stuff to an array. Unlimited potential, and I just push stuff to an array. Cool, so yeah, here's another example where if you wanted to return a promise for an API request, that will work as well. It's all kind of the same thing. All right, so that context, we talked a little bit about it. It's an object shared by all the resolvers. It is mutable, and for every request, you create a brand new one. You can mutate and do all your stuff, and then you can destroy it at the very end. You might use it for the authentication data. Like maybe you're making a GraphQL proxy that talks to a bunch of other SendGrid or Twilio APIs, hypothetically. And you want to stand that up, like, cool, yeah, you're going to still need that other person using it, their API key. Right, you're not going to be like, hey, let's just make my API key publicly available. It's fine. You can say like, all right, we're going to pass that through from the request, and we'll create the GraphQL service, but we're going to take that additional information and use that as well. You can take the entire request object if you think you're going to need it to make additional requests as you go through as you navigate through that tree for the resolver. If you have a bunch of abstractions, like if you're using a library or an SDK for all of your API fetching functions, that'll work as well. If you're using like connects or whatever thing you're using for talking to a database, Mongoose or whatever, you might choose to pass that through as well. This is really great because like when you start breaking stuff into multiple files, you don't have to like require it. It's getting passed through the entire tree for all the resolvers. Also useful if you need to then replace it with other stuff while you're writing unit tests, because unit tests are good. So this is the example from the documentation, but you can see they're passing in an auth scope, which is just getting the request headers, and then it's used in each of the resolver once in that third argument as a property on it. All right, so we're going to look just at some code and just figure out some additional things that were just awkward to put on slides, and then we'll explore stuff and answer any questions as well. The other thing is if you looked at any of the code slides, you can actually like play with the API as well, so we can actually take some things for a spin if you have some questions along those lines as well. So you can go to this website. I actually have it open in Visual Studio, and I want to kind of touch on cheat sheet. How to add those additional properties. Like we didn't want to actually have to query for an artist and get their name. If we want to have that with the song, we can look at how you might do that. And we'll look at a second example that does make AJAX requests, so we can just see that in action as well. And you can play with them, or you can like challenge me if you think that I lied on any of this. We can just go, I think I didn't. That's why if I did, I wouldn't have put it online. But we can do that as well. So just kind of jumping into the code real quick. Two hands. Bigger, bigger. There we go. Less pains. No sidebar. All right. So here's the entire schema. You can see that I added an artist name and an album title that are supposed to be strings. Now these are not in the data, right? They're not on those song objects. They're not hard-coded in there. All I put in was the artist ID and the album ID. So if I wanted to add these to the resolver hypothetically, I could go ahead and you can see that all of it's basically doing the same thing. It's finding the artist and the album in this case, but it's going ahead and getting that property. So now I don't necessarily have to write the longer query. I can create shortcuts, and the resolver can handle this custom logic for me, and everything is great. Now, yes, is this a contrived example? Sure. Does anyone want to read really dense code at 7:15 at night? No. So, but you can kind of like see how you might like pull it forward along those lines as well. And let's go ahead and we'll look at one that uses promises instead. And we can fire these up. I have it running in a tab as well. And so in this case, I'm using a Discogs API that I'm just abstracting over with GraphQL. And so what that's going to do is, in this case, they have releases, and then you can get the songs in there. So it's a little bit of a different schema. But I did the first example first, and I wasn't rewriting it. Where I'm just pulling off certain things off the API that I wanted, which is the name, some profile string, the real name of the artist, the URI for the Discogs site, and their releases. And then a release has a title, a year, and an artist. And we can go ahead and get a particular artist because that is a very, like they don't have a get all for artists because they sell vinyl for a living. It's all the artists. So for getting a particular artist, we've got that argument that's coming in where we'll just make a AJAX request. I guess it's not AJAX if it's Node, right? It's just a network request. I'm a front-end engineer, can you tell? And we'll go ahead and we'll make the get request, and then it's on the data in Axios, so we'll be able to return it, right? And so this is returning a promise, which waits until it resolves. And even then, if we also need to get the releases, that is a separate API call in the Discogs API. So first, we'll get that first data, and we'll have access to the artist ID because we have access to that parent. So first, we figured out the artist, then we went down to figure out what all the releases were. We could still walk back up the tree, right? And this is one of the things, like ASTs are super powerful. That's what powers Babel. It's what powers ESLint. You can do a bunch of fancy stuff, in, just breaking stuff into trees and walking up and down them. I'll see also the DOM. And we'll go ahead and then we'll fire for artist/releases with that artist ID, and we'll go ahead and get the releases as well, right? So I can kind of like abstract different APIs. If I wanted to also hit last.fm or something like that, I could do it in these resolvers and start to combine the information and do it all on this like abstraction layer. And then as I'm building the client, I don't have to worry about this stuff, right? I don't have to do some of the really shady stuff that some of my coworkers find in the code that I wrote and get blame is cruel. So, yeah, that's the kind of high level. I'm happy to like either flip back over to the, I got a little playground running, or we can look at any of the code, or I can just answer random questions.
What are some patterns you find helpful as your resolvers start to grow to like hundreds of thousands? Can you combine Redux, combine reducers, that sort of thing?
Yeah, I mean, the short answer is start breaking it apart, right, and have a meeting about folder structure. Everyone's favorite meeting, or whoever makes the first PR. But you can break them up, and so some of the things you can do is in the it's gonna be hard to live code with one hand, so it's gonna be a little hand wavy. Here I have this GraphQL kind of type def. You can actually like break that out into a GraphQL file and actually just require the string that goes to the file location, right? In this case, like this, if you think about it, is a JavaScript object. And you think about, nowadays we even have like the spread operator. So you could begin to require all of them, very similar to combine reducers and Redux, right? Where you can break them out into individual files, import them all, and then like add them all to, create one object that kind of merges each one. And, if they have sub things you need to do there as well, you can begin to like require them, right? Like the worst mistakes that I've ever created to a code base is where I start to dynamically read the contents of a folder. Probably don't want to do that stuff. You probably just want to add each line one by one, because every time I've done that, it's worked out poorly because I'm not DHH and I can't get that stuff right. But you could theoretically also like start to write a tool that would traverse the folder at like compile time and like add them all in there as well, like using something like Babel too. But I would argue that most of the time that is premature optimization. But the core thing of like these at the end of the day, and yeah, are there other implementations in other libraries? Absolutely. But in JavaScript, like this is a JavaScript object, right? This method could just be a function that's an own file that I import or require like on the fly. So you can do that, and just your normal JavaScript best practices go a really long way. It's one of the things I like about resolvers and GraphQL, as well as the example you had of like Redux, of like at the end of the day, it feels overwhelming, but it's just objects and functions the whole way down. Right, which is very relieving. And like the whole goal of this talk is like, oh, that thing when I read the documentation it intimidated me. It's just JavaScript functions, which, in fairness, JavaScript. But the end of the day, it is those very kind of like simpler primitives there as well. Anything else?
We got queries and mutations. Mutations and queries.
Yep.
Is there a good way to talk about that without all that?
No.
All that verbiage? Because I have seen people talk about just queries, and that sometimes covers mutations.
Yeah, I don't know.
There's a group.
Yeah, this is a group question.
Talk about that. Because it is a mouthful.
It is. Yeah, I think Craig made a point with his slide where there was just, we hadn't even, could you add subscriptions in here too? Yeah, you could. Right. I decided, again, it's late. Yeah, I don't know if this is condoned. So if someone wants to again, there's fruit you can throw at me. I treat, they're probably all technically all queries. That's right. But queries for me is the get and the mutation is the post. Right. I mean, subscription is like a push notification of a WebSocket. I'm not even dealing with that right now. The getting and the pushing. Yeah. Mutation is probably a query. Is that true? I don't know. I say queries for get. I'm not the authority on this one, though. It's one of those things that I never thought about until you asked this question. I keep saying words right now that I haven't really thought through.
Well, I think a public client, they'll do query. Now refer to a mutation or a query. Yeah, you still have to identify it maybe at some level, but
yeah, it's hard because you end up having to talk about and explain code more than you have to type it. Right, so it's whatever makes sense to the people you're talking. It's probably like on a team by team basis. Yeah, I don't know. I don't have a satisfactory answer for that question. And when I answer a question, I can answer, so we can leave on a high note.
Do you like GraphQL?
Yeah. And what I like about this is that, like, I think that they're, again, like, the trick that we have to solve for is they're like, organizations are hard, right? And a lot of times the cost to benefit is unfortunately unevenly distributed, right? Which is the front end teams greatly want it. The back end teams aren't really going to benefit. And like, on the architecture team, we do worry about like, there are trade-offs, right? Like there is the fact that like, is this an extra hop that we have to do that adds latency? Sure. Like could you get really fancy with Redis and caching and stuff like that and somehow make it faster? Probably. Right? Is it like a slam dunk all the time, right? Like when it's the very first thing in an organization, you're not going to accidentally DDoS, that the front end team is not going to accidentally DDoS the back end team by writing some kind of circular logic. It is, absolutely like a concern in both ways. But I think having the ability, like as front end engineers to basically spin up a back end for front ends, autonomously and independently is really like core, because like it's not always, at companies where product managers a lot of times get to set the roadmap, that may not be a thing, right? Like there are deadlines, there are features, right? You can accelerate the front end. That doesn't mean the back end teams, product managers, like, yeah, let's do it, right? And so I think the kind of ability to be able to put up those middle tiers is when, obviously measure it, right? If it's like adding a bunch of latency, then that's problematic. I would also argue that, and Harrison can back me up on this, you can probably go find some shitty performance that you can solve for that will buy you the latency, right? Like if you're getting to the point where the only bottleneck in your application is your GraphQL like middle layer that does an extra hop, you're in a great position, right? We have bigger fish to fry. What is it, 8 megabytes with all the bitches? I'm sorry, I don't know. This is not. You actually, it's client side. You can see where all of our bodies are buried in the Chrome tools. But yeah. I think like the ability to actually control some of your own destiny there and be able to create these abstractions works out really well. And also like it's a nice architectural pattern to have that middle tier. For the marketing campaigns app that Craig works on, when we first started it, the APIs were in flux. Right, and we didn't use GraphQL for that one, but we built an intentional middle tier that every API request went through, so that if anything changed, because it was also the team's very first AWS set of APIs, and they weren't sure. Right, so by having every request go through a middle tier, by definition, should any of those API contracts change, you change it in one place, and the rest of the UI layer doesn't care. This is effectively pushing that pattern on you, right? Which is you're creating a bunch of things like, I need artists, and I need albums, and I need songs, right? I can build out a really, really robust client-side application. If some of the, like, let's say all of a sudden we're hitting a different API endpoint, I won't have littered AJAX requests all over my app. Everything's going through one layer where I can change how it is we get that data, right? Direct in a database through an API, so on and so forth. It also forces good just general architectural patterns onto you as well. So yes, that's a really long answer to say yes. I started with yes though too, so I pulled it back around. Yep.
GraphQL being like language agnostic, is the implementation fairly similar in other languages in terms of resolvers? Like would you be able to step into another language and be like, oh yeah, I can implement GraphQL?
Here's the thing about being a JavaScript engineer. I don't have to. I don't know. I can write server-side JavaScript or client-side JavaScript. I should learn Go. I'm just not going to. Because I don't need to. I don't know. Yes-ish. It's fine. I don't know.
What was the question?
Is it roughly the same in other programming languages? And I got smug and said, I don't have to learn other programming languages because I can use it on the client and the server. It's the one true language that we're all stuck with. All attempts to kill JavaScript have failed. It's immortal. It's not as bad anymore, though. It used to be terrible. Anything else?
I was going to say, in answer to both those questions, there's a GraphQL spec that defines a lot of these things. Query and mutation are resolved words within that spec that define the graph. So it's kind of whether you call it a query, it's basically just a fetch operation, and they define the entrances into the graph. And then checking out the GraphQL spec. So that's
light reading.
There's a good video. Stephen Lusher, who used to work at Facebook, or maybe still does. 0 to GraphQL in 30 minutes, 30-minute YouTube video. He writes GraphQL server in Ruby and Python, and then a JavaScript one that consumes both of those, all in 30 minutes. So you can see how to build GraphQL server in 3 languages, and it's like a lot in 30 minutes, but it's very easy to follow.
They're generally
It's cool.
GitHub repos of pre-built implementations.
Yep.
I think there's a page called GraphQL Anywhere. It's like exactly that. It's implementation in whatever language consolidates.
Yes. The crowd says yes. All right. Thank you so much. Oh, one more. Tim, what's up?
Are there any instances where it doesn't make sense to use GraphQL, or should we just start using it everywhere?
Yeah, so this is something we deal with on the architecture team at Twilio sometimes, which is, adding that layer, right? Creating a new service does involve a non-zero amount of risk, right? And sometimes that risk pays off, right? There are, for SendGrid's user model, for instance, right? It's like an ungodly amount. To get everything you need to figure out like what this user has permissions for, it's rough, right? The team that has to work on it is sitting in the back row. They're nodding. And so the big, there was, it came out like, okay, do we put a GraphQL middle tier in there, right? And we approved that blueprint, but there was a definite question of should we just add an endpoint that isn't fucked? Right, and that is one line of SQL and a new endpoint that would have just gotten all that information as well too, right? And so by adding an extra layer, you could solve a bunch of problems, right, by giving yourself a good architectural pattern, but you also add complexity, right? And sometimes we just need a better endpoint for this? It's worth having that discussion in a 3-hour meeting.
You're talking about specifically putting the wrapper pattern around it already.
Yeah, so this is a 10-year-old series of API endpoints that have to figure out what the actual user is and what they have permission to require at least 10 API requests, right? And so the proposal was to create a GraphQL abstraction over that gets everything, but then it runs down what if we just made an endpoint that got you everything, right? And that's a conversation you need to have, right? If you're going to need many different mutations of it, sure, then it makes sense. If you only need it once and you need all the properties to do anything, maybe not, I like to say that all the easy things are going to put off to the compiler and we're only left with the hard choices that we have to have meetings about. But yeah. All right. Thank you so much.